Hey, good afternoon. I'm not going to sing for you, given the way the room looks, but I'm going to speak about how to build an IT/OT strategy. But before we start, just to encourage you to ask questions at the end, we have a couple of T-shirts for the ones that ask the most interesting questions, or for the one that just ask questions if there's not too many questions. We'll see how this goes, right? So my name is George. I represent OPSWAT. The OPSWAT office in Romania is in Timișoara, so we have a local presence. And if you want to know more about the company after the talk, we can meet at the stand we have out there. Right. So what I want to start with is discussing the perimeter, right? And all the talk is going to be centered around file security in the context of the perimeter in those networks. What you see on the screen for you, for some of you, it might be familiar. The architecture that you see there is the Purdue model, right? Which is the golden standard in OT networks. Is there anyone here that knows what OT stands for? Show of hands. Yeah, there's quite a few. For those that don't know what OT stands for, it's operational technology. So think of it industrial networks, right? It's probably the easiest way to put it. And obviously, there's a big push with zero trust in the last couple of years. And what zero trust does is just blurs the line of the perimeter, right? So the question is, does the perimeter still exist in the context of zero trust, in the context of cloud adoption? Is it just diluted? Is it gone completely? We're going to try to tackle all those story points. The question is, where does the IT network perimeter end? Right. So what you see on the slide there, it's just a couple of examples of different type of threat vectors, let's call them, right on the top, and those usually sit in the IT network, right? When we talk industrial networks, there's always an IT component. So the equipment that runs in the IT network, the standard applications that you're all used to, but there's also an OT network, which historically it's been air-gapped. So there was essentially nothing connecting the two together, right? That obviously has changed in the last couple of years. And we're going to look at how the convergence between the two networks introduced new risks. Right, so I think it's a difficult question to answer, right? Where does IT perimeter end, especially when we talk about cloud, and we're going to look at that. But then we have to look at where the OT where the OT perimeter starts. And again, there might be some overlaps. There's obviously something in between the two, the connection between the two, right? The convergence. And that's what's in between, really. So we're going to look at those threat vectors. And again, back to the IT story. The cloud adoption has introduced some serious challenges for in protecting the IT perimeter, right? That expanded dramatically. The attack surface grew exponentially, and we need solutions in line with the new threat vectors that exist in the cloud workloads. And there you can see some of the threat vectors that exist in there. And what we're going to try to do is talk about the challenges in the bigger context, right? So the challenges that we see are from a customer perspective, essentially, are coming from different type of regulations that are enforced on those customers. And you can see some mentions there. NIS2 directive, I think everyone's heard about NIS2 extensively in the last couple of years. We failed to implement it in October, shockingly. It wasn't only us, right? It's 2 countries in Europe that actually managed to do it before the October 17 deadline. And that's Belgium and Croatia. The rest are still in the process of implementing that. And obviously those regulations, some countries are pioneers when it comes to regulations. And you see USA there, obviously they're big into regulation and cybersecurity frameworks. They have a regulation specific to nuclear. It's called NERC-CIP. Australia is a fast follower, and they have their own, right? Like they did with GDPR, like they did with all the cybersecurity frameworks. And obviously there's other countries, like this is just a snippet of the main geographies, let's call it. But it's not only regulations that push customers to improve their cybersecurity. It's obviously the fact that they're being targeted. And those attacks become more difficult to prevent or defend against. Those are nation-state sponsored attacks, especially if we speak about critical infrastructure, right? Those are complex systems that need a lot of skills and knowledge on how to manipulate those systems. You have some examples there. Stuxnet, I'd be surprised if it hasn't been mentioned in those 2 days at the conference. Targeting nuclear sectors, specifically Iran. It was the first example of a cyber attack that actually manipulated physical systems in a nuclear power plant. Right? The story goes that US and Israel unofficially collaborated in building this very advanced cyber attack. Black energy, we're probably more familiar with that, given the vicinity with Ukraine. Russian-sponsored attack targeting the power generation utilities did a lot of damage in Ukraine, but got out of hand, of course, and managed to affect some customers in Australia. And in Europe, ransomware, obviously, affecting all sorts of different customers, targeting pipeline operators mainly. But there's all the challenges as well, right? And the pandemic has taught us we need to be a bit more mobile. There's a lot of users that want to work from home, not only, in R&D and software development, but also operators, right? And then that brings all the challenges. So in the IT space, what we see is that accessing sensitive and privileged networks is a big challenge, right? You have users working from home that need access to different tools in the network. How you give access to those users, it's really, really important. You need to be specific, and we'll talk about the strategy that you can implement in building a solid cybersecurity framework in tackling those challenges. But we have supply chain risks as well. Anyone here heard about the SolarWinds attack? Quite a few, yeah. Probably the best example on how supply chain can affect that many organizations, where a threat actor managed to, let's say, change the behavior of a very popular software that's used globally by the biggest enterprises out there. So the need to secure third-party libraries becomes a lot more important in the last couple of years. In the US, they actually passed a law that says if you're a government entity and you need to buy software, that software has to come with a software bill of material attached to it. So you know exactly what are the libraries that make up that software, what are the vulnerabilities associated with those libraries. And like we've seen in many cases, the US, obviously, they're pioneers when it comes to that. So that's probably going to trickle down to Europe as well. And there will be regulations looking at supply chain and how we protect against supply chain. In the OT space, the challenges are somehow similar, but it's a bit more nuanced. You still need to give access to remote people into the network, but the equipment they need access to, you know, it's a lot more important than a database server in the IT network, for example, right? If they do something wrong, the operations might stop, right? And that might have physical consequences, right? It might generate to some sort of chemical leak, explosion, and whatnot. And we've seen that, right, with the Colonial Pipeline, where they used TeamViewer, I think it was, and that's how they got access to some of the systems. But they have a supply chain challenge as well, but it's slightly different, right? A lot of the equipment is pure hardware in those networks, and the hardware can be bought from, or it's made in different countries in the world. We all know about the 5G concerns around Chinese vendors, right? So that applies to the OT operators as well. The hardware that you buy needs to come from a friendly nation, let's call it, right? Transient assets. So transient assets means USB devices, laptops that we carry across networks to do some sort of configuration work, troubleshooting, and whatnot, right? And those introduce risks. The fact that you're from a trusted vendor and you go to your customers to do some work using your own laptop doesn't mean that's risk-free. There is a degree of trust, but the actual customer needs to be able to implement its own security measures on your equipment, right? Otherwise, you're the one introducing risk to that network. And just like in the supply chain scenario, ideally, they would have the same level of security to the customer they go and visit. Doesn't always happen, though. And obviously, looking at the network, there's a lot of traffic of data. A lot of data is generated and stored. And we need to be able to make sure that the data that's generated and stored or maybe received from untrusted sources is virus-free, let's call it. So those are the challenges if you picture them as dots, right? Those challenges, those dots need to become defense lines. And that's what I'm here to talk about, how we take those challenges, what are the strategies that we can apply to connect those dots and build a robust cybersecurity defense line or a defense in depth methodology, let's call it, in protecting what's most critical in our society. The 3 points that I want to make here, those are the biggest challenges if we were to summarize everything we've discussed so far. So minimizing the attack surface is probably the most important one. The smaller the attack surface is, the less prone to cybersecurity risks you are. Securing the data transfer is as important. Maybe a question for the audience: how does almost every cybersecurity attack start? Anyone wants to try answer that? Reconnaissance, that's the initial stages. I'm talking about the actual event. It's a user opening a link or a file, right? It's the payload. So that's why the data is so important, right? Making sure the data is safe and secure. So you don't have to rely on the users as the last line of defense. Obviously, inevitably, you'll do that, right? But we don't have to put all the security strategy we have on the user's shoulder. And that ties down into how you build an advanced threat prevention framework, what technologies you use in preventing those advanced attacks that we see targeting those networks. So the part one is looking at the IT perimeter. So we're going to break down what's in the IT perimeter, what are the threat vectors there, what's the targets, and what's the strategies that we recommend. So in any big IT environment, you'll have web portals where users can upload files. All right, that can run in the cloud, it can run on premise, doesn't really matter, it's a threat vector. Right, so you have users in the internet being able to upload files to your network. Let's talk here. Let's take here a use case. Let's say banking. Right, everyone can now open an account using a mobile app or going on the bank website. You just have to upload your picture of your ID and maybe some other documents, and that's it. You have your account. It's fantastic, right? It's so useful. But then that's a big risk for the organization that runs that web portal. It's very easy to weaponize files now. You know, there's so many tools out there and large language models that can help you write some sort of, let's call it undetectable malware. It's slightly debatable if it's undetectable or not, but what I'm trying to emphasize is you don't have to be a genius to be able to write a piece of malware that might make it to the target. And then obviously the targets there are the business applications. That it could be API gateways, and like I said, it could be any portal that's external facing. And what's the strategy there? What can we do to protect against that threat vector? So the solution, the cybersecurity solution that's implemented has to be able to scale with the number of transactions that's actually increasing day to day. So having a solution that's easy to implement and easy to scale would help the company to scale down rather than scale up rather than scale down, right? The last thing we want to do is slow down any business process with cybersecurity tools. We want the customers to be able to protect their workloads and do it efficiently. And obviously, there's a lot of migration to the cloud. So the solution that's implemented has to be super flexible, has to be able to run on-premise and in the cloud as well. And obviously, you know, using Docker technologies and Kubernetes and whatnot. But most importantly, it has to be efficient. It has to be able to block and detect and prevent known and unknown threats, right? Because if it's a nation-sponsored attack, they're probably going to invest a lot of money into developing that attack, and it's very likely they're going to test it many, many times before the attack happens, maybe just scanning it with multiple AV engines to see if that's going to be picked up. And only once they're certain that traditional AV engines won't be able to detect it, the attack would happen. So here we need to look at how we implement cybersecurity solutions that have a layered approach to security, instead of just relying on one type of technology that's detection-based, right? A lot of customers would use AV engines in a combination with a sandbox to protect against known and unknown threats. That's fantastic, but the issue is both the AV engines and the sandbox are detection-based technologies, right? If they're not able to detect the malware, then the threat actors have a chance in succeeding. So what we need to introduce here is a pure prevention technology in this layered approach. All right, let's move to the next one. Just like I said, supply chain is obviously an important factor here. There's a lot of libraries being used, public libraries being used in the software development lifecycle, and that's obviously the target, right? I think it was beginning of this year where they uncovered many vulnerabilities. The last one was on 7-zip just this week. and that made the news. Obviously, there's a lot more libraries out there that are heavily used in business applications that have vulnerabilities. But the code is going to be also used to develop internal applications. And then the strategy we can take to mitigate that is to support virus integrations. And the reason that is because we want to encourage the developers to shift left. We want to encourage them to have security in mind. And we can only do that if we don't really slow them down, right? If we have an integration that allows them to do their job, but we provide the security layer on top, that's going to make them happy, right? And that's going to keep the company safe as well. And obviously that solution, again, back to my point, it has to be able to handle both cloud and on-premise sort of deployments. And it has to have the ability to provide prevention capability. Detection is not enough. We've seen that many, many times where customers run the best cybersecurity products in the market and they still get breached. And that's because most of the customers have a layered approach to cybersecurity. You know, they try to apply the defense in depth concept, but everything they add in that layered approach has the same working principle, right? I'm trying to detect it, and I can block that. But what happens if you cannot detect it? Right? Yeah, there's a big advantage in using multiple vendors that do the same thing, but if they do the same thing in the same way, it's not going to make all the difference. Emails, right? For years, it's been the most important threat vector for those networks. And that's because everyone uses emails, and that's because social engineering can trick users in clicking URLs, in clicking or in opening attachments, and it still is the most common way of delivering payloads into an organization. But it's not only emails, right? It's collaboration tools, it's messaging applications like Teams and whatnot, right? Users exchange files over those tools as well, and they are being targeted. So the strategy is layered defense, like I said, but keep in mind not using the same technology only, not only detection-based layered defense. Just like before, cloud and on-prem doesn't change, right? Customers migrate from Microsoft Exchange to 365. There's maybe a handful of customers that still use Microsoft Exchange. A lot of them have hybrid deployments. So the security solution that comes to beef up the security for the email has to be able to work in both environments. And because users interact a lot with those potential threats, we need to pay additional attention to their training. There's many companies that provide cybersecurity training and awareness for users because they're the last, they're the last line of defense, if you wish, in that concept. And the security strategy is as solid as the user training is. And obviously, cloud storage, right? A lot of companies have migrated to the cloud. Almost everyone uses OneDrive or some sort of cloud storage. We've seen many, many cyber attacks hosting payloads on the likes of S3 buckets, OneDrive, to try to evade being blocked. You can't really possibly blacklist OneDrive URLs in the firewalls. So threat actors know this, they take advantage of this, they use legitimate tools to deliver their payloads. So it's very important to scan any cloud storage or on-premise storage. And if you have a solution that can do seamlessly both of them, that's golden, right? There's no effort in implementing that. And again, collaboration tools, right? A lot of that, Teams, for example, stores the files in OneDrive, right? So it goes to a cloud storage. The strategy there is to manage the entire life cycle of data. So you need to be able to scan the files as they come into the network, but that's not enough, right? You need to be able to implement regular scans of those files. And when we look at the OT network, that's even more important because files in the OT might stay there for years, right? There's regulations that would force them to store them for 5, 7 years and so on and so forth. It does happen in the IT space, in banking as well. And you need to be able to audit and trace all the file operations as well in that space. And if I haven't repeated that enough, threat prevention capabilities are really, really important. But there's another risk, right? Users logging in from home, using their mobile phones, using their personal laptops, tablets, and whatnot. And they can introduce risk that way. A lot of companies provide VPN services to facilitate that. They deploy AV solutions, but that's not always enough, right? You need to be able to make sure the device that's logging into your network adheres to the standard that you want to implement, right? And the standard can be the device has to have a local AV installed, it has to have a full system scan in the last couple of days, a number of conditions that if are not met, the device won't get access to the network. Right? The stricter the rules are, the more secure the device is, but obviously there's always a trade-off there. And we can refer to that as multi-factor endpoint access control. Right? The same way we have multi-factor for user identity, we need to have multi-factor for device identity. And obviously, constantly monitoring the health and the compliance of that device, and if something goes wrong, you need to be able to remediate that, either automatically or get IT to work on it. Right, so that's it with the IT. I think those challenges are quite basic. I think everyone faced that. We're looking at the OT perimeter. Some of those concepts might be new to the ones that didn't know about OT that much. And hopefully after the session, some of you would be a bit more, for some of you, it's going to be a bit more clear what are the threats for industrial networks. So the bigger threat there is USB devices. You'd be surprised how many customers still use USB devices. You'd be surprised if I tell you that some of the most critical operators of critical national infrastructure use floppy disks still. Those are still attack vectors, right? If you need to transfer files into a network that's not connected to any other network, the only way you can do that is by using a USB or external hard drive, some sort of portable media that you copy the files to, and then you go and do your job in the destination network. And traditionally, this was done to protect that network, right? So if it's not connected to the IT network, we assume that a lot of the IT threats won't be able to reach the OT network. That has completely changed in the last decade, and we see a lot more connections between the IT network and the OT network. The reasons there are many, right? The biggest one is you need to be able to know what happens in the OT network so you can optimize the cost and the efficiency. And you need the logs for that, and you need data. But once you do that, you want to be able to automate data transfers into the OT network as well. But if we stick to the peripheral media, the targets there are essentially workstations, SCADA devices, or any industrial device that has a USB port essentially. Anywhere where you can put your USB in and you can copy data, that's a target. Back to the Stuxnet story, right? That's how Stuxnet spread out on a USB. So the strategies is to have a strategy on handling USB devices or portable media. A lot of customers have a strategy, and the strategy is, I have a computer that's not connected to my network, and it has a local AV installed, and I use that to scan the USBs. If the AV says everything's fine, I trust it completely. That's one vendor. So essentially, that's putting all the eggs in one basket, right? If that vendor fails, you fail. You get breached. Not a good practice. You have to audit the data exchange. Like I said, there's a lot of data moving back and forth. You have to be able to audit that. And you have to be able to upgrade the threat prevention there, right? We see more and more attacks targeting critical infrastructure. Just adding a firewall, it's not going to do the job, right? OT network operators would have to step up their cybersecurity in using purpose-built OT cybersecurity solutions. Right. Like I said, there's a lot of data that has to be replicated, right? And that's done by historian databases usually. And that is a big concern. Industrial devices generate a lot of data that has to be consumed, usually in the IT network, where all the operations are, and they need to look at the data and make some decisions, which means the OT network gets connected to the cloud with Industry 4.0 and Industrial Edge, and it gets connected to the internal IT network as well, which means once you have a payload inside, you can exfiltrate data, and then you can hold them for ransom that you're going to publish the data. Or obviously, if it's a nation-state attack, you can still, all sort of blueprints and so on and so forth. So we need to secure the transient devices, again, devices that leave that network, and use data diodes. If you guys know what an electrical diode is, there are diodes for data that use the same concept and approach. It's allowing the data to flow only in one direction. And the benefit of employing a data diode is that it gives you the reassurance that the data can't really flow back. And that's mandated by NERC-CIP in the US, for example. We've discussed about NERC-CIP. If you're a nuclear operator in the US, you need to use data diodes. Otherwise, you can't operate the nuclear power plant. And use threat prevention technologies. Detection is not enough, even in the OT context. We do have people logging in and accessing OT resources from home as well, right? The pandemic caught us unprepared. So what happened is a lot of those organizations have deployed VPNs, gave access to contractors to do their job, and that solution stayed. But it's using an IT, a technology designed for IT, used in the OT context, which doesn't really work well in many cases, right? Essentially, you give access to that device in the network, right? Lateral movement is then going to be a lot easier. So what we need to do is provide secure remote access, which is a terminology for remote access solutions dedicated to the OT environments, right? And those have to essentially be able to do protocol level monitoring. And when I say protocol, we're talking industrial protocols, right? Modbus, S7, and whatnot. Depending on the vendor, they use their proprietary protocols. You need to be able to block connections if something goes wrong. And to do so, you need to understand the protocol, right? Just having a VPN is not going to do the job. It will give user access to the resource, but that opens a big, big risk. And obviously, making sure the endpoint that they're connecting from is secure, is compliant with the standard that's acceptable for you as a business. we go to the lowest part of that diagram. That's where all the equipment that manages the process itself runs, right? It could be sensors, heat pumps, whatnot. ATMs, if it's banking, for example. So industrial devices that get targeted because they're the crown jewels, right? That's the ultimate goal of an attacker, to get hold of industrial devices to maybe stop some sort of business process. And the strategy there is to use microsegmentation. Right? In the OT context, the 62443 framework talks about zones and conduits and how you can do microsegmentation as a best practice. Customers in that field have to be to follow that cybersecurity framework, otherwise they get penalized. And again, those would use proprietary protocols, so you need to be able to look into those protocols as well and decide if you need to block something or not. And increase visibility, right? There's going to be plenty of devices in that network, and if you don't know what devices you have in the network, you can't possibly protect those devices. So in summary, the three takeaways are minimizing the attack surface, securing the data transfer, and using prevention combined with detection. Seems super simple. It's very difficult to implement, but a lot of organizations do that. And a bonus, there's 2 QR codes there. We have 2 community services. If you scan the QR code, you can go to those 2 different websites. One is a full sandbox that allows you to do any dynamic analysis you want. Emulation-based sandbox, so it's a next-generation sandbox. The other one is our community service for multi-scanning, so you can upload files there and get it scanned with, I think it's 30 AV engines now, and use the prevention technology that I kept mentioning here, blocking 0 days. Right, that was the presentations. Anyone that wants t-shirts? Questions?
Thank you. We can...
Thank you.
Let's take a couple of questions. Raise your hand. We have one in the front. One here and then one there.
Thank you for your presentation. I have a question, like, I actually have 2. Like the diagram in the beginning, the architecture diagram, where do you get that from?
So it's called the Purdue model. It was developed by Purdue University. If you Google Purdue model, you can get it. You can go on OPSWAT.com and there's an explanation as well.
And like most security certifications and trainings are about IT security. And for OT security, what would you recommend for people to study if they are more interested in it?
Very good question. Let's make it clear, we haven't talked about this before. That's because we have a training program that focuses on OT cybersecurity. But you do deserve a t-shirt for this question. No, the reality is you make a good point, right? A lot of the training is centered around protecting IT systems, and there's plenty trainings about IT security. OT cybersecurity is slightly different. For the OT people, security is secondary, right? For them, most important thing is for the operations to run 24/7. So the approach there is slightly different. On OPSWAT Academy, we have a lot of basic trainings for beginners on OT cybersecurity, from explaining concepts all the way to how you should program securely like an S7 Siemens PLC. So there's a big push on our side to work with the vendors in the industry to create content, and we do add new content regularly. A lot of those trainings are free, some are paid, depending on how the difficulty, essentially.
Let's take one more question. He was first, sorry. No, go there because he was first, sorry.
Thank you for the presentation. Any of your devices can act as a, let's say, command sanitizer between an engineering workstation and the PLC. So if I'm issuing some commands, right, I need to put some parameters there. And the machine accepts from 0 to 200, but I know that 100 is very dangerous. But I'm still typing, instead of typing 10, I'm typing 100. Is any of your devices able to send a message or block the command and tell me, are you doing the bad, you are doing the bad thing?
Yes.
Rethinking.
Good question. So that's mainly a job for a industrial firewall that sits behind, before the PLCs. Yeah, with a bit of machine learning and the ability to look into the traffic, so with deep packet inspection, and the ability to understand the traffic and the parameters that are allowed, we can block actively, or we can just notify. Blocking is not, OT people are not a fan of blocking, obviously, because that might just, give them headaches if they block something. But they for sure want to be notified if something is off, so they can act. But yeah, and it's not only OPSWAT. That's usually a job for industrial firewalls, and that's why I said using IT design systems for OT is not always the option, right? You can put an IT firewall there, but it won't do much in that situation. Thank you for the question.